Hi my friends, today we model this part, which is a skeleton, a chair skeleton. But before, I want to show you something else. If you want to find my tutorials, you have a very easy way. Right here, fast group fastgroup.ro/tutorials, then enter. Click on this and you have here a lot of assets for that tutorials which need some assets, but the main data is here, general index table, which has links to each tutorial. You see, go to one you want to see, for instance this one, click here and then the tutorial 155 is presented to you. This is the way to find my tutorials, which now are over 230. Good. Let's go back to our lesson of today. The source for this tutorial was this picture taken by a former student of mine. You see, there is only one pipe which is bent to become a skeleton for a chair. It has here a special punch and two other cuts or holes. The drawing is this one, and it contains all the necessary data to create the model. Remember dimensions of the pipe. 25 is the external diameter and the wall is 1.5. Dimensions are 450, 450, and the height is 400. You see, the measure is from this face, which is the base for the chair, to the mid of the pipe. Yes, we have to remember this. Okay, the other elements are not so important. We'll see during the modeling. Remember also the radius 50, which is placed all over the contour of the chair. Good. We start with the standard millimeters IPT, and the first thing we do is to get access to the parameters. This access is placed here by me, but you can find it here. Parameter, right click and select this, add to quick access toolbar. You'll find it here. So we use this shortcut and we create a numerical parameter with the name pipe. Units are millimeters. Okay, and the value is 25. We'll use frequently this dimension So I want to have it as a parameter. User parameter. Now we apply a particular strategy by creating a plane firstly based on this plane. Let me turn this isometrical. This plane is the base, and we move it up to the value of 400 minus pipe with a capital P, pipe divided by 2. Okay, we don't see anything here, so I go to File, Options, and I change the colors to dark. Okay, now we see here something. Let's see what is this. This is the plane. The plane up from the basic plane, which is this one. We use this new plane to create a sketch. The sketch is a rectangle, but centered in the center point, with dimensions of 450 tab 450. Finish sketch. But now we see that these diagonals are construction and the other are not. So I go back to the sketch. I want to move this dimensions. Why? Because I want to make every lines as construction lines, because they are used as support. Good. Now a new sketch in the plane XY here. F5 to see again the plane. This is the plane. I project all the lines which present the square, not diagonals. Finish sketch. Then I create a 3D sketch, not 2D sketch, but 3D sketch. I select line and I use points from this two sketches to connect them and to create the main part of the skeleton, as you can see here. Escape. Good. And now what? Now I apply bend with the value of 50 to create fillets of this contour. Here I cannot select a point like here, so I select separately the two lines. Here I can. Here I also can. Also here. Also here. But now I cannot select this because it is a point with 4 lines. I select separately the 2. The last is this one, and we have the axis of the pipe. But I told you that this must be a 25 diameter pipe, so I have to extend this line to the bottom with half of pipe parameter line. Start from here to somewhere, then the dimension of pipe divided by 2 and aligned with the vertical line. Okay, the same in the other end, a line which is equal to this one and also aligned with the vertical line. Good. Now we can go to creating another sketch at the end of this short line. Finish 3D sketch and create a new plane by using this line and this point. This is the support of a sketch. F5 to be in the same view. Circle. What is the diameter? But I don't get this point because I have to project the short line. Circle. What is the diameter? The diameter is pipe, my friends. 25. Finish sketch and sweep. This was selected. It is the only close contour here, and we select the continuous 3D contour to cover it with the circle. Okay, good. These sketches and the plane are no more useful to be presented, but they must be there. Good. I select the material, which is still carbon and polished, still polished, to be like in the model. Then, you know, we have, let me hide also this plane. We have a massive pipe here, not a tube. So we have to use shell with the thickness of 1.5, excluding the 2 bases. Okay, now it is a tube, you see? Okay, next we have to create this beam, which is placed at 150 from the center point. The center point is somewhere here, yes, on this horizontal and this vertical. it is placed at the middle of the pipe. Yes, dimensions are 25, radius 5, a slot, and 1.5 is the thickness. Then we'll create this hole or slot, another slot. Okay, we select this plane, which is the mid plane, for a sketch. The sketch must be somewhere in the air. Slot, horizontal, and radius. Dimensions, as you know, are 25 with 5. Why this movement? Who answer me? It was here, yes? And now it's here, because this is a homotetical view of the slot about this point. Yes, this point is the center of homotety. Okay, now I have to place dimensions here. I have dimensions from the drawing, which are 400 from the center point. Dimensions are measured from the center point. Center to center, 400. And center to center of 150. I apply offset of 1.5 and I obtain the slot with thickness. Finish sketch, extrude. We extrude this contour to the part. I want it to be in the other direction and to the part. Not okay, but plus. What is this? Oh, this is not 400, my friends. This is 400 minus pipe divided by 2. My fault, my friends. Pipe divided by 2, because it was extended here. Okay. Then I apply extrude of the contour like this, the other direction, and to the part. You see, this is the solution. Plus the same external contour also to the part. You see, this is maintained. Okay, we have the beam here. Let's see what about the slots. The slots are at 107, but let me clarify here. You see, this was moved down with 25 with pipe, and the center point is up, is here. So the distance from the center point to here must be 400 minus that half of the pipe parameter. These slots are 6 with radius 3.2 and 170 placed on the mid of the beam. Remember this. We go here and I rotate to be X to the right. I create a new slot somewhere here, horizontal, and with that dimensions of 6 by 4 placed at the distance of 150 to the center point, from the center point 150, and the other distance after I apply. Now I wanted to mirror the sketch. I mirror the feature. Yes, I'll mirror the feature to obtain the other one. Now I place a dimension of 170 divided by 2. Yes. Finish sketch. Extrude. We have a close contour, this one. This is why I need to select. If I made this construction lines, the contour were already selected. No problem. Through all is this slot. Good. Now I use the midplane, this is the midplane, to apply mirror. Mirror of the last feature about the midplane, which is this one. You see we have here the result. Okay, that's good. Next and last feature is this one, which has a hollow and a hole. The hole is through the part. You see, the hole is through and the hollow is up. Dimensions are here. 90 degrees of cone with 12 diameter up, and the hole is 6.4, a radius of 2 for the fillet of the of this edge. Very interesting. And where is this placed? This hole, one of them, is on the horizontal with the slot and placed on the 45-degree axis of the part. Good. let's work, my friends. The first thing I do is I want to have a half of the part, to see half of the part, and I need to create a plane. The plane is based on this bottom plane and on an axis, the axis of this. Now you see it is mid-plane, this one, diagonal mid-plane. Then I apply half section view by using this plane. Okay, now we look inside the part. Yes, we have half of the part. Good. Now I have to make a special sketch, a geometrical based on this plane, but up somewhere here. I project the two generator, 1 second, and I create a sketch. You will see that I use only some aspects of this sketch. I draw a line here and I finish it perpendicular on the other. You see, perpendicular, but also equal, with a distance of 12 between ends. 12. Then I draw a new line, a horizontal one, but first I apply offset with the dimension of the thickness of the pipe, which is 1.5. Then I cut with trim these small ends here and here. And now you see I can move the second line. Oh, I don't like this. I want them to be at the same distance. This is why I place a dimension. You see, when you disturb the offset result, you have to place dimensions. The offset is lost. Lost. Okay, now I draw that line horizontal with the dimension of 6.4. The dimensions of the hole. Another one is placed here, also horizontal, equal in length with the first. What a construction, my friends! Why? Well, you'll see why. I apply now two driven dimensions. The distance between the upper generator and the upper line, 2.8. I accept to be driven dimension. Okay. And another one also from the upper generator to the second line, also as driven dimension. Escape. Let's see the table of parameters. Excuse me. The table of parameters. You see these two reference parameters, and I give them names. Upper is the upper one, and bottom is the bottom one. We'll use these two parameters, and we can forget the sketch. Finish sketch, hide the plane, and we create now another plane by using this upper sketch. We apply plane based on this bottom plane and the line from up, or a point, not a line. The angle is 90 degrees. Okay, this is the plane. No, it is not good. Control Z. I'll use a point, not a line. Plane, bottom, and this point, my friends. Now I have the plane I want to have. Very good. What about this plane? No, this is the reference again. I create a plane based on it and to the bottom minus, and the value is upper. This is the upper plane, and I use again the same plane, this one, to place a minus bottom plane. You see? Now I hide this one. Oh, but it looks like the James Webb Telescope layers. Yes, these are layers of our telescope. Visibility. Good. Now I have to make a first sketch, and I project this arc. I place a point somewhere. I project also this line. I place the point on the, where is the point? I place it on the line, and on the same horizontal with the center here. This is good. Finish sketch to see what happens. Okay, I activate the sketch, F5 to see the former position, and now I use this point to draw a circle with a diameter 6.4. Finish sketch. I select the other. Now I can hide this plane. I select the other plane, F5 to go back, and I project this circle on the new on the other plane. Finish sketch. Now we have two circles. I can hide also this sketch and the plane. We have two circles and I apply extrude. Extrude with taper. The bottom one must be oriented up and have 45 degrees because 90 is the cone, 45 is the taper, and which goes to the cylindrical external face, this one. You see? Okay, and then plus, I apply plus to keep the extrusion active of the other circle, but using cut and the same angle through the part. Yes, we have the two new walls. Okay, see, now I select this to create a sketch, but I have the sketch now, and I apply extrude with cut, and I want to go through the part, yes, to penetrate through this wall, but nothing is below, so I can apply through the part. Okay, now you see we have the hole. Let's apply the fillet of 2, which is by default. Let's eliminate the half section view, and now we have the feature. Which does this feature contains? It contains material extrude with taper, a hollow with taper, a fillet, and a hole. 4 features. So I go to model, I apply mirror to all these 4 features, 1, 2, 3, 4. About the plane, we know which plane we used it, XY, and you see we have an idea. Now we have the feature, real feature, which is through. Both are through. This means that we are at the end, my friends. Let's see what is the volume. Properties, physical, update, and we copy this all value. We go to the drawing, double click, and paste. You see a small difference because there are some differences in procedure, not by not important ones. You have now the part, the drawing, and you can try to model the part. That's all for today. Thanks for watching. Bye bye.